In this problem, we're told a hypothetical planet has a radius 2.3 times that of Earth, but has the same mass. What is the acceleration due to gravity near its surface? So in order to solve this problem, there's this formula you need to know. So the acceleration due to gravity near planet's surface, right, is going to be equal to g, which is the gravitational constant, times the mass of the planet, or whatever planet, right? So in this case, we have a made-up planet, and that's going to be over the radius of your made-up planet, or whatever your planet is, squared. So this right here is the formula that you use to solve. So let's go ahead and write down the variables that we need to do this. So you notice that we need g, which is the gravitational constant. And so this is just a number that you need to memorize, which is equal to 6.67 times 10 to the minus 11. So you need to know this number for this. And then we need to know the mass of our planet and the radius of our planet. So keep in mind, it says the radius is 2.3 times that of Earth, but has the same mass. So the mass of our planet is the same as the mass of the Earth. So the mass of the Earth, you should memorize this number. It's going to be equal to 5.98 times 10 to the 24 kilograms. So this right here is the mass of the Earth. And so keep in mind, it's going to be the same as our planet, right? So that's going to be that number. And the radius of our planet is going to be 2.3 times that of Earth. So essentially the radius of our planet, right, is going to be equal to 2.3, or r sub p, right? The radius of our planet is equal to 2.3 times the radius of the Earth, right? Because it's 2.3 times that of Earth. So r sub e, right? The radius of our Earth 2 times 2.3 is the radius of our new planet. So essentially the radius of the Earth, you need to know that it's equal to 6.38 times 10 to the 6th meters. So this right here is the radius of the Earth. So we just got to multiply by 2.3, and that's going to give us the radius of our planet. So 2.3 times 6.38 times 10 to the 6th. If you go ahead and do that, you're going to get, all you got to do is just do 6.38 times 2.3, and then just leave times 10 to the 6th at the end. So it'd be 14.674 times 10 to the 6th, and then meters. So this right here is the radius of our planet now. And so all we have to do now is just plug everything in, right? Because we have every variable. So we have g on top, 6.67 times 10 to the minus 11 times the mass of our planet, which is the same as Earth, 5.98 times 10 to the 24, and then divided by the radius of our planet squared. So this number is squared, so 14.674 times 10 to the 6th squared. So let's go ahead and find a. We can just solve this. So what you do is you take 6.67, multiply by 5.98, and then divide that number by this number squared, right? So 6.67 times 5.98 divided by 14.674 squared. If you go ahead and do that, you're going to get 0.1852. And then we have to do times 10 to the whatever, right? So it's going to be times 10. So what you do is you add your exponents up top. 11, or minus 11 plus 24 would be 13. And then down here, 2 times 6 would become 12. And then you subtract the bottom one from the top one. So 13 minus 12 would just be 1. So times 10 to the 1. If you go ahead and do this, you're just going to get 1.852, right? Because you just move the decimal point over. So 1.852. And then keep in mind, they're asking the acceleration. So our units are going to be meters per second squared. So the acceleration due to gravity near the surface of this planet is going to be 1.852 meters per second squared. And so yeah, hopefully you found this useful.